Hi, it's P8.1, Linear Relations. So, first step is knowing how to plot points on a graph, your x values and your y values, knowing how to create a table of values, and that's one of those things that looks like this. And then you can fill in whatever numbers you want for x, and then use the equation to figure out what y should be. Okay. Knowing how to describe the slope using these words: increasing, decreasing, vertical, and horizontal, and I've got some examples coming up of that. Tell what the slope of the graph says about the relationship being shown. So if it's an increasing slope, maybe that's the growth of a tree. If it's decreasing, maybe that's temperature going down in your fridge or something. The value of $1, maybe the value of my bank account going down. Identify real life situations, well, we just did a few of them, bank accounts and trees and temperature, where you would actually use linear relations. Describe, draw, or model the relationship shown in a line graph. Matching equations, this one's kind of fun. Every equation could be matched to an ordered pairs, x and y values. You could show it also in a table of values, and you could draw it on a graph, or you could draw it on a picture, maybe trees getting bigger or bank account getting smaller. So lots of different ways to basically show the same information. You could find missing parts in, maybe there's an ordered pair that's missing, and you could find that on the line. Maybe you could find a missing value in a table of values. And maybe you could see that there's a pattern going on. So example, if this was 2, 4, 6, what's the next one going to be? You know, without doing any math, it's just following the pattern. Tell whether ordered pairs fit on the line of the graph, and identify situations that cannot be shown with a solid line graph. So I didn't talk about this in the rest of the slides, so I'm going to do this one now. If there's a solid line graph, you'll know from the graphing lessons that we did in grade 8, line graphs are always used to show a trend. And so if your tree is 1 foot tall today and 6 feet tall in a couple years, at some point along the life of that tree, it was 3 feet tall. It hit every stage of growth, right? It didn't just one day, poof, it was 6 feet tall. It grew steadily, maybe faster, maybe slower, but it hit 2 feet and 3 feet and 4 feet at some point. And so growth of a tree is something that could be shown. I guess it would never go down, would it? Maybe there was a big windstorm and it knocked off a foot. It could happen. Okay, so growth of a tree is something that could be shown with a connected line graph, solid line graph, because it was definitely this tall at some point, and it was definitely this tall at some point, and it was definitely this tall at some point. But there are some situations that cannot be shown with a solid line graph. For example, if I'm going to ask students, let's see, we'll say number of students is up the side here. We have 1 to 10, and I'm going to ask them how many hours they spent on homework. And so we've got that on the side here. And you can say that this guy said 1, and this guy said 10, and this guy said 7, and this guy whatever. And so you couldn't really connect those values because nobody said 6.5, but I have a spot on my graph that goes right through 6.5. And so that doesn't make any sense because that actually didn't happen. And so there are some situations that you just cannot show with a solid line graph. Okay, just a quick review of plotting points. Make sure you go in the house and up the stairs. So let's look at our green set of coordinates first. The value is 2, 3. They always give the x value first, the y is always second, and your x value is your horizontal. Go in the house. So we always start at the origin, which is 0.00, that purple one there. And we're going to go 2 in the house, and then 3 up. Okay, -3, 1. We're going in the house, the back door, I guess, and up 1. Should make these the same color. This one has a decimal place, which is fine. We can do that. -1.5. So in the house, -1.5. And -2.5. 1, 2.5. Okay, just a quick review of that. Now, graphing a linear equation, and you'll get more practice in the next outcome with this too as well, 8.2. So how do we graph linear equations? Here is an example of an equation, and then they've made a table of values, and they've put, it says down here, the x values are picked by you. You get to pick the x values. That's usually the case, is you can pick one or the other. And so it doesn't matter what you put in for x, you can plug in any number you want in there. I wouldn't plug big numbers in because more chance of error, so I always use 0, 1, 2, maybe -1 or -2, and that's what they've used here. It's very common. And so then if you look back at our equation, wherever the x is, that's where you're going to pop that number into. So they've highlighted the -2, and they're going to pop that number into their equation right there and see what happens. Okay, so they figured it out. 3 times -2 is -6, and then subtract 2 more gives you -8. So if the x value is -2, that's what they popped in here, the y value that you're going to get is -8. And that's just how a table of values works. So whatever you input, then you see what your output is. And table of values, this -2, -8 can be shown on your Cartesian plane. There's -2, and then -8, 3, 4, 5, 6, 7, 8. And you can see it's on the line. So let's pick another value down here, 1, 1. And if you put 1, 1 into this equation, 3 times 1 is 3. Take away 2 is 1. So 1, 1 checks out. It does fit the equation. And here it is on the graph. In the house 1, and up the stairs 1. There it is. Looks like happy face. Examples of slope in real life. We talked about the growth of a tree. That would be represented with a positive slope. Downhill would be like my bank account. Every time you write a check, money's coming out, or use your bank card, or do any spending, money comes out. It's very sad. Horizontal slope, maybe they use that in construction to make sure that there is no increase or decrease if you're building a railway or a road. And vertical slope, they say it's undefined because technically you'd be dividing by 0. There's no change in slope. And so it's all just y values. There is no x. And so the slope is undefined, but basically that just means it's vertical. So things like a rocket ship taking off, you would want a vertical slope. The indicators say that you should be able to take an equation and turn that into ordered pairs and plot those onto a graph. So here is just another example of how that's done. So here's our equation, y equals x plus 4. It's the magical formula that's going to happen inside that x and y chart. So you get to pick the x values, pick anything you like, and so in this example we've picked 5. So if I plugged in 5 right there for my x value, 5 plus 4 equals, I hope you said 9. So the x value is going to be 5, and the y value is going to be 9. So our ordered pair would be 5, 9. If x is 3, plug that in instead. 3 plus 4 is 7. So if x is 3, y will be 7. So our ordered pair, always put the x first, is 3, 7. Careful with your parentheses. You don't want them to look like 1s because that would be 13. It should be very different. And last one, if x is 1, 1 plus 4 is 5. So ordered pairs, 1, 5. Now you could easily plot those out on your graph. These are all positive, so I'm only drawing that quadrant of the graph. We don't need anything more. And let's say we've got 5, 10, 15. 10, 15, just eyeballing it, not very accurate. Our first ordered pair was 5, 9. And so we're going in the house 5 and up 9, so right about there. There's our first one. And the next ordered pair is 3, 7, the purple one. So 3 and up 7, about there. And the orange one is 1, 5. 1, 5, right about there. And you can see if this was a real graph, it would probably be a straight line. But it's pretty close. For me, I don't draw, so it's as good as it gets. Okay, happy graphing.